Hello everyone. Now we are going to learn about HECRAS flood modeling in this the remaining section of HECRAS flood modeling. Mm, After editing the geometry, you can open the geometry from edit option, and then your next work is to insert values of Manning's coefficient in the table, mm, and go to edit, go to tables, Manning's n or k values. These values are based on land use and Mm, before that, do LHCR first after selecting the row. Yes, okay. And then N1 is the right bank, N2 is the center bank, river center line, and N3 is the left bank of your river. So the value can be different for each of the sections. You can even change the values from here after looking at your sections. And now I am going to show you a table from where you can copy the values in my flood modeling. You can, first of all, you need to observe your area. In my left side there is most of the part is agricultural land, while in the right side there is forest or sand. Most of the part is sand, so I am going to enter the value of sand here. And in the left bank I am going to add the value of agricultural land if it is available, and the center line is normally in the river path, so I am going to enter the value of water. Let's go to this interface table, Mannings, and in the left in the right bank most of the part was sand, covered by sand. You need to interpret each of the point from here and change each of the values, but for now, to teach you, I'm going to add similar values for all the sections. N1, for N1 there is sand, so I'm going to enter 0.030 in N1. Go to set values, 0.0, sand 0.030. Click on OK. It has been changed. And for N2, set values, N2 is the river center line, so I am going to look at this, the river. So 0.040 is its value, 0.040. Okay. And for the right bank I am going to change these -999 values from forest cultivation area. It is the cultivation area, right? So I'm going to enter 0.035. Set values 0.035. Okay. After entering all the values, just click on OK and go to file and save geometry data. After saving this geometry data, you need to insert discharge data for different return period. So you need to go. You can even cross this section because it has been saved. Now go to edit and steady flow data. We have the discharge data of 6 return year period, so I am going to enter 6 here, and this is steady data Rapti. Now I am going to enter the discharge data for each of the stations. I have saved the discharge data, HECRAS training. Inside HECRAS training, hydrological station data Rapti, and this is my discharge data. I'm going to enter one by one. First one is 2807 for 5 year return period. For second year return period, it's 35 year, and for third, it's it's not copied. Human error. Reduce. And then again just select another and enter Control V, and again Control V, and again Control V. After that, you need to set the reach boundary condition. In upstream side, in most of the time, we use critical depth, and for downstream, we need to compute the normal depth. For computing normal depth, you need to go to this, watch this cross section, and look at the highest elevation and the lowest elevation point. Here, the highest elevation x represent the distance, while y represent the elevation here in this graph, and the value changes. You can see the change in value in this section, in this space here. For this point, I think this is the highest point, and the elevation of this point is around 524, while this is the lowest point and the elevation is 400, 300, 342, right? So, and so I'm going to open MS Paint now. Paint, the highest value size is, to calculate the normal depth, you need the highest elevation 524 and the lowest elevation 327. 5, 524 minus 300, 327 divided by distance. Distance here is distance of the overall river path. Distance is from here. This is the starting point 0, and this is the ending point. Till this point, the distance is 586 meter. 586. Now it is equals to, I'm going to calculate 524 minus 327 divided by 586. It's 0.3361. 0.3361. I'm going to enter this value in normal depth. Put this MS point. Enter the value in normal depth. Select the normal depth and 0.3361. Okay, okay. After entering all the discharge for different return year period and it is boundary condition, just save the file, save the flow data, save it as flow data. Okay. After saving this data, cross everything and go to run, and steady flow analysis, and then compute. It will take some time. After computing, go to RAS mapper, uh, OSIT. I have crossed everything. Again, I am going to load that file. File, open project. Under Saptakosi, I have saved it under Saptakosi. Saptakosi, terrain, Rapti project. Okay. And to view your result, you can go to the RAS mapper. Go to RAS mapper and then results. You can double click on it. This is your depth. You can even add the wave imagery, and to see the changes in the depth for different written year period, you can move the cursor from here. This is the depth of 5 year written period. After that, the depth data will be like this in 10 years, 50 years, 100 years, and 150 years finally. Similarly, you can even view the result of velocity. This is the velocity, river velocity, right? And you can even see the color and the velocity of the color rank. Velocity increases as the color appears red, and in this section there is high velocity, while in this section there is lower velocity. Similarly, you can change the velocity data to, and the final output is the water surface elevation. Now, to create the hazard map, you need to export this layer, export raster, and the cell size of my digital elevation model is 12.5, so I am entering 12.5 here, and I'm going to save this data in 103 media, desktop 103 media, under dim velocity for written year period 5 years written. Okay, stored, and then again I am going to save the data velocity, depth of 5 year written period, data, export layer, export raster 12.5 meter cell size. Okay, now I am going to show you the hazard map, how you can compute hazard map in ArcGIS Pro. This is the data. This is the final flood modeling output. I'm going to open this, insert new map, insert new map, new map. I'm going to work in this. Go to insert map, add data, browse, 103 media, images. Mm, I think I have not saved the data here. Desktop 103 media on the bias, or it's not on the bias, I think it's inside dim, but I am again going to save the data. I forgot the path where I have saved. Export. Export raster Saptakosi terrain. Oh, it's saved under Saptakosi terrain. Now I'm going to edit from here. Add data. This specificity Saptakosi, and inside terrain it is. It was saved as velocity right here. Yes, I'm going to load it, and again I'm going to add another data, that is depth for 5-year return period. And this is the velocity data and this is the depth data. I'm going to change the color ramp from this, and I'm going to inverting because but okay. Uncheck this and generally this is the velocity map. And again I'm going to change the depth of the color, depth symbology. I'm going to use this to create the hazard map. You need to go to analysis, tools, raster calculator, calculator, click on this, and then use the simple operation, simple multiplication operation here, depth into velocity, and choose your output location. Mm, I'm going to save it here. Hazard map, hazard, flood hazard, flood hazard. Okay, run. It has been completed. Uncheck these layers and symbology. Go to symbology. mm, Classify natural breaks. Use natural breaks here. Symbology. Change the color ramp. This represents the hazard map here. The color represented in the red is most hazardous, while you can even see the flood extent, the hazard over here. Mm, let's load the next wave imagery map, base map, imagery. Okay. This is your final hazard map. These are the hazardous area, and I'm going to end the video now. Thank you for watching.